Travis?
No, I just camera died and I wanted to make sure.
Hey,
Lauren.
How are you?
I'm good. How are you?
I'm great.
Good. All right. Hey, here's the idea.
More kind of graphic.
No.
From the top, boys.
Sassy.
Okay, anyone else need graph paper?
Yeah, me. Just kidding. April Fools. Oh wait, it's October. October Fools.
All right.
Oh yeah. Yeah.
Stop talking. It's getting annoying.
That's on recording.
Are we recording?
Yeah, I'm recording. So, all right, section 1.3. It's obviously based on functions and their graphs. Now, the big thing that I want to talk about today are goals. We've got to do piecewise functions. Those are the 4 problems we're going to turn in. My goal is to do 3 problems to practice right in the beginning. These are practice problems, so we can get used to like how to do them and stuff. So if you have like notes, you can put these in your notes. That way you get practice. These are not the ones you're going to turn in. Now, the goal today when we start graphing these, number 1, obviously with piecewise functions, can you even graph them accurately? Do you know where the numbers are? Do you know how to identify if it's a line or a non-linear function, like a curve? Those are the big ideas. Now, obviously things we will discuss in this class today. We're going to talk about domain and range. That is not a part of the homework you're turning in today. That's a part of the page 172. There's a couple problems asked for domain and range. That's just to help clarify some stuff. We'll talk about minimums and maximums today. That is not a part of the assignment you're going to turn in for me today. That's a part of maybe that assignment. There's a couple problems that said find a min and max. And then obviously increasing, decreasing, and constants. That's a part of the graph today when we draw. You do need to kind of like, not identify the parts, but you need to be able to like understand when you're looking at it, if it's going up or down or flattening. Like that's a part of like if it's a line or a curve, like you should identify what it's doing. Okay, does everyone understand what we're doing today? We're going to do 3 examples. I'll clearly kind of mark them as examples. And then when we get to the homework, like what we're going to turn in today, because we're going to do it together in class, I'll have them clearly marked. I even have a slide that says these are the 4 problems we're turning in. We'll go through them and I'll explain the rules when we get there, how we're going to do that. Okay? All right, so this is the first problem. So if you're in your notes, this is my first one. This is how I'm going to label them today. I'll give you graphs like this. We're going to kind of walk through them. Okay, so on this problem, when I look at it, there's 2 pictures I'm going to be drawing. The left side and the right side. There's 2 pictures. When I draw these, the big thing is they're both linear. They're both straight lines. The reason why I know that, there's no powers. So I know they're lines. I can see that right away. I know that for each of the lines, I have to plug in 2 numbers. For each of them. So I'm going to try to color code as we go. So the first one I'm going to do is I'm going to do this one in black. I'll do the bottom one in green. Okay, so that way you can get a sense for like which picture is which. You do have to draw both on your notes, so try to make sure that you understand. So let's do the first one. Now, when I do this top one, this is the formula. This is the actual numbers I'm plugging in. I always recommend use the number that I have printed, or if there's 2 numbers sitting there, maybe it's like between X and this, use both numbers I have printed.
Perfect.
Okay? So for me, I have to plug in 0. Now, what are other numbers I should be plugging in?
1. Negative.
Negative 1, because I should pick other numbers that are less than 0. So I should plug in negative 1, or negative 2, or negative 3. Any number less than 0. Now, the first dot that I'm plugging in, the first 0, that's an open circle. This is the part some people were really getting confused about during that 4th period today. Because they didn't understand, like, how do I know if it's open circle or not? Is there a bar underneath this?
Yes.
Open circle.
No.
There's no bar, so it's got an open circle.
Bar means closed.
Bar means closed. Okay, now, do we understand the main difference there? Okay, now I'm just drawing the top one. I'm going to put this in, in fact I'll switch it up, so I'll put it in green. Sorry, I'll put it in green so we stay color coded. Sorry, alright. So, here we go. Okay, for the first one, I'm going to plug in 0.
0.
What's 0 with a negative sign in front of it?
0.
Negative
0. Negative 0 is still 0. Now, if I plug in a negative 1 with a negative sign in front.
Negative, or 1.
Positive 1. Now you don't need to put plus, I'm just putting positive 1 because the 2 negative signs cancel. So I'm going to go graph that. The first dot I'm graphing is 0, 0, and that's an open circle. Okay, because I couldn't include it. That's again, I'm doing this part. Can include it. The next dot will be closed. So negative 1, positive 1. So negative 1, positive 1. And I know I'm using all the numbers to the left.
Wait, we need this or this is no?
This is examples. Okay?
If you read the board.
So that way you can get an example of it. So you can see what we're going to do. Now, the second graph, this one, I'm going to be plugging in 0, and it will be a closed circle right away. And Now I have to pick numbers that are greater than 0, so I'll pick like 1 or 2 or 3. Doesn't matter. I always just pick 2 numbers. Now, do we understand why it's closed in the open circle?
Yeah.
Yes.
Bar underneath it is closed. So when I plug in 0 first into this formula, 0 plugged into x, I just get 0. If I plug a 1 in here, I just get 1. If I plugged in 2, it'd be a 2. So I'm going to start at 0, 0. That is a closed circle, so they're actually overlapping each other. They just happen to be overlapped. And then my next set is 1, 1. And that arrow is going that direction, because I can pick all the numbers greater than 0, so I can go to the right. Okay, is there any questions with this graph?
No, 0.
Now, on this graph, obviously if we talk about the main things here, domain is all real numbers. I can have every x that I want. The y numbers, like range-wise, it starts from 0 and goes up, basically. The minimum, it actually has an absolute minimum at 0, 0.
0, 0.
There is no maximum, it goes up to infinity, so there's no maximum to this graph. But those are like little things. This graph has both increasing and decreasing. It is decreasing on this side, as I go from left to right, it is decreasing. It is increasing on this side, there's no constants on this graph.
You use parentheses, right?
Yeah, you'd use parentheses on this one because they'd be sharing if you're doing like the decreasing, increasing thing. Okay, questions at all about just the graph in general and how I did it? Because some people just need to see like, how did I pick the 2 numbers? How am I getting the answers? Because they just need to see like the simplicity of doing it. We get it with that one. Second example. Let's do the second one now. All right.
Uh-oh.
All right, second example here. Same exact thing again. Now I'll use some different numbers. When I look at these, here's what I identify. There's no curves on this problem either. There's no powers. This one's a line. This one's actually a constant, so it's a flat. It has a number, so it's flat. That's how I know it. I'll explain that one once we get there. I'm going to try to color code them again. I'll put the top one in blue. I'm going to stick with blue the whole time. I'm not even going to pick the other marker. All right, orange. So, going on to this next one. So the first number I'm going to plug in is a 0 on that top equation, because I'm using this number, and it is a filled-in circle, so it is a closed circle.
And it's also...
And now, the other numbers, I got to pick x's that are less than or equal to 0, so I'll pick in like -1. You can pick any number you want. If you want to pick -2 or 3, that's fine, whatever you want to do. All right, so this is my first graph. I'm going to plug in 0. 0 times 2.
2.
0. -1 times 2, that's -2. So there's my 2 numbers. So when I plugged in 0, 0, that's a closed circle again, because it had the bar underneath it. And when I plugged in -1, I got a -2 out of it. -1, -2. And it's going to the left. I can use all the numbers less than 0. So I can use all the ones to the left. Okay, does that make sense, the first graph?
Yeah.
Trying to be as easy as possible. Second graph. I'm going to use, let's use red, I guess. All right, so on the red graph here, I'm going to start at 0.
There you go.
So I'm going to start at 0, and it's got to be an open circle there. This is an open circle at 0, because it has no bar underneath it. And I can plug in any numbers greater than 0, so I'll plug in like the number 2. I'll pick different numbers this time. Any number greater than 0. So I can pick 2, I can pick 4, I don't really care. You can pick more than 1, I always just pick 2, because these are lines. Alright, so for the second one, when I plug in a 0, there's no x's to plug in, right? There's no x's here, so the answer is just 3. It's just a constant answer. It's not changing. There's literally no x's to plug in. So, my answer for 2 will also be 3. If I use 7, my answer is still 3.
Where'd you use 10?
10, 3.
What
So,
about 12?
3. Now, here's the idea. The first dot, 0, comma 3, that is an open circle. There, because I was not including it. 2, comma 3, and 7, comma 3. And that graph is horizontal going that direction. It's going to the right. Do we see that whole numbers are just constants? They're flat. They're horizontal. Okay, so far these are just the basics, right? I want to get you used to like graphing, getting used to the number systems. Okay? All right, questions on the linear graph. The first one's kind of normal. The second one is new. We haven't done one like that where it's horizontal. This graph does not have any decreasing side. It's increasing on the left up until 0. Then it's constant after 0. There's no decreasing as I went from left to right. It does have a maximum. I know it seems weird. The maximum here is 3. It happened at 3 multiple times, but there's a maximum of 3. There is no minimum to this graph. The domain is literally all real numbers because I can use every x. Every x is accounted for. The y's though, the y's for the range is really goofy. It goes from like -infinity up to 0. and then there's another number at 3. All right, questions?
Next.
Next. All right, here we go. Last example. This is my last one, then we'll get to the actual in-class activity where you can turn in something, get some points. Okay, so this one, I picked this one on purpose. It has some curves. So I thought we'd better do one that has actually curves to it. Okay, so we have 2 different graphs. I'm going to color code these again just so you can kind of see them. I'll do red and black here. So the first one I'll put in red. Now, when I plug in my first number, what's the first number I'm going to plug in?
0.
0. And is it open or closed?
Closed.
Closed, because it has the bar underneath it. Okay? And now the next number I'm going to pick is any number less than 0, so I'll pick like a -1. Now these are curves, so I'm actually going to plug in a couple numbers. Since they are curves, I like to at least have a few. I may not be able to graph all these dots, but I at least want to plug in a sum so I can kind of get a sense for where this thing is going. Now, we're doing a cube, right? We're doing a power of 3. So when we plug 0 in, 0 to the power of 3, 0. If I plug in -1 to the power of 3, I get -1. -2 to the power of 3, that's -8. The power of 3 keeps a -7.
-27.
And then, yeah, -27 for the next one. So that's the one dot I won't be able to draw. So the first dot is closed circle, it's at 0, 0. Then it went to 1, 1, 2, 8, and 3, whatever, so there you go. There's where that graph's going. Okay, so there's my curve on the left side. The right side, I'll put in black here. Okay, we're going to plug in 0 first. It will be an open circle. I'm going to plug in 0. So 0 squared times 4 is still 0. I'll plug in a 1. I'll plug in a 2. I don't know if I need to plug any more than that. What was that? Oh, is it supposed to be negative? Oh, I went the wrong way. Sorry, hold on. Apologies, I forgot to make this.
Mr. Ward, you're gonna have to edit that. You can't be wrong
I can make
yourself.
mistakes, I'm fine. Alright, so sorry, I forgot the negatives. Alright, so move down, sorry. Alright, so now, the right side. So again, apologies, I forgot the negatives. So, that was 1, 1, 2, 8.
Draw it.
Alright.
Ah.
For the next side, 0, 0. When I plug in a 1, 1 squared is 1, times 4 is 4. Plug in a 2, 2 squared is 4, times 4, that's 16. So I won't even be able to draw that one. So 2 is too high. But so 0, 0, that's an open circle. 1, 1, and then 2, 16 is way up there. And it's kind of going up, and I think I'm going the right direction on that one. So on this one, there is no max or min. It has every x accounted for because I know it overlapped in the middle. There was an open circle and a closed circle that overlapped each other. The range is literally every number. So this one, there's no real gaps. This thing is actually considered continuous. It flows from the left and right side. All right. So that was the last example here today. All right. So here we go. All right. So we're gonna do the next 4 problems we're going to do together in class. So, let's see, doing it? Yes, I'm going to restart it. All right. All right.
Should have got a sandwich on TV.
Quick. It's out of ammo. Quick.
Reload.
Happens every time when the network hiccups for the day. I have to restart it, so it's fun doing it 10 times a day. All right.
How many times?
10.
You counted it out.
Yeah, it's ridiculous. It's happening all day. Every single class is done it.
How many minutes does it take for it to
Is it just there or is it like every day?
It takes a minute or 2 to reboot. All right, so the next 4 problems we're gonna do. I'm gonna put them up on the board.
4.
I'm gonna put them up on the board. You're gonna draw them. Now, I'm gonna give you on the first problem. I'll give you 4 minutes. That way you get a sense for how to draw
Turn
it.
this in, right?
We are going to turn this in. So you do need your final graph paper here. We are going to turn these in. Bless you. So hopefully this will make sense. Once we're done with this problem after 4 minutes, we are going to go through it together in class to make sure you did it right. You can make fixes if you need to, because I said we're going to do these together. I want you to at least try it without me inputting. You can work together with a neighbor if you need to, but let's keep it on 4 minutes, because I will, at 4 minutes, show you the answer. And we're moving on. I want to see that you've actually attempted it. There's going to be a problem or two that you may not have any time where I go through it. So it might be one of those things where you just have to try it out and just hope for the best on that one. So, all right, so these are the 4 problems we want to go through. Okay, so first of the 4, here it is.
Oh, we don't
Okay,
need-
so this is problem number 1 out of 4. You have your 2 equations. These are the numbers you should probably be using. You should know if they're open circles or closed. You should know if they're linear or curves, or if they're constants.
Oh, boy.
Where'd he go?
Sorry, it happens. It's going to hiccup constantly. You might just have to plug it in old school.
Dude.
Anyone know what the second equation was?
X plus 3.
No, that was the first one.
X minus 3.
In fact, I'm going to freeze that before it hiccups again. There we go. All right. Here's your first one.
Less than. Is that less than?
Less than -2, greater than or equal to 2. So you're at 4 minutes here. Yeah, actually another. I'll put a timer up on the board here.
Graph it out. Good descent, right?
That's all we have to do?
Just graph it. Pretty easy.
Probably
About
not.
2.5 minutes.
This is going down?
Let me see.
Or up?
Let me see. that.
Yours is right.
Isn't
No, it's right.
that right? Oh.
Right?
Let me see.
Did you go on two?
Okay, remember we have homework due tomorrow. Keep that in mind.
Well, I was just going to say my thing, so.
I both say like that. Coach.
This is going up.
Okay, yeah, we're gonna go through these together. Hopefully you get a chance to draw this.
To
Get
the
a
right,
sense
to
where
the
it's
right,
going.
to the right, to the right.
That's right.
Coach.
Jared, you did it wrong.
Oh, I probably did it wrong.
You're trying to tell me I did it wrong, and you did it wrong.
Kevin doesn't do it wrong.
And I did it right. I know
Or
something
is
about
he messing?
I'm never wrong.
You're never wrong.
Oh, why does it look like rocks?
I messed up.
Oh,
I can't remember one time my
Brock's not right. Brock's never right.
really?
Remember that, guys. Brock Gouge is never
Not
right.
relying on for my math skills. I won't get you far.
Brock, you better turn around and tell the
Okay,
whole
got another minute here.
One of the
Better
closed.
tell the whole world.
Yep.
Yeah, Mark.
Mark.
When?
Look,
No, can I just not show up until the dress?
big close.
I don't know if I did it right. I think
Close.
I trust
Nope.
myself.
Closed.
We're under a minute.
Our class is very heavy, isn't it? Closed. No class out.
Adam, sing your song.
I don't know.
You're so shy on camera, aren't you?
Oh, God, it is
Okay, 30 seconds.
You didn't sing your song.
He'll edit this part anyway.
No, you won't.
Fast forward.
So how's the
Pause.
person working so to have time to do it? If they're watching the video.
What?
If you're watching the video, don't you need the time to do it?
Watching videos. Watching videos.
Doing math
Alright.
like it's in.
Okay. All right, let's go through the answers here. Let's talk about how to calculate it. So first one, it's going to be an open circle at -2. This is a line, so you should know it's a straight linear equation. And then I got to plug in numbers less than -2, so I'll plug in -3. I can plug in any number I want that's less than -2. I just plug in that one. Now the first stat, remember, is open because there is no bar underneath that inequality symbol. So when I plug in -2 plus 3, that is 1. And then -3 plus 3, that's 0. So at -2, I'm going to get an answer of 1. And at -3, I'm going to get an answer of 0. And that graph is going this way, but the first dot was open circle. So there you go. So -2, 1 was an open circle, everything else was closed. So there I was going down to the left because I use every x to the left. Now the next numbers I'm using are 2 and any number greater than 2, so I'll just pick 4, doesn't really matter. I can pick any number I want. And these are closed, at least the first one's closed, just because it has a bar underneath it, so I can actually include it. So when I plug in 2, 2 minus 3, that is a -1. When I plug in 4, 4 minus 3, that is a 1. So 2, I get a -1, and at 4, I get 1. And I went that direction. Now, again, you could pick any number. I just picked those two at random. You know the first number you have to pick, but I just picked other ones. There's your graph. That's what it should look like. If you're doing minimums and max, there's no minimum or max to this graph because it goes forever. Domain, it would be over a certain set. It stopped, and it picked up the next set. Range is literally all real numbers, even though they overlap. Because you can, range is every y number. It's actually, because there's overlap, so it actually covered every number. But there you go. So there's the first one. Hopefully that's what your graph looks like. If it doesn't, make a quick adjustment. Maybe you went the wrong direction. Maybe you plugged in the wrong numbers. Who knows? All right, the big thing I'm checking for. Do you have open circles, closed circles? Is there arrows?
Yes.
That type of thing. All right, let's go to the next one. Where's my graph? Okay, so second problem here. Out of 4.
That's number one.
Click on the wrong one.
Maybe.
Clicked on the wrong one.
Hey.
All right, second graph. So, you have nice clean numbers. I'm trying to pick an easy one for you. You have nice clean numbers,
She's
3 and -3, and these are the domains you're kind of working over, so you should know if you have open circles or closed. You should know if it's a line or a curve or constant. Kind of go through graph. I'm going to give you 3 minutes on this one. So I'm going to kind of cut these next ones down because they're kind of easier. Until we get to number 4, and then that one's a doozy.
She's closed. She's open. Okay, got about 2 minutes left here. Toss it.
Toss the wood. Toss the wood, bro.
Just a piece. Guys are done.
Hey, what lead you got? 0.7? 0.5.
Not another.
About 1:30 left.
Can we get some more time? Can we get some more time on this one? I'm stumped.
I'm done. Dude, that went the wrong way. That truck went the wrong way. That is not an exit.
Not an exit.
I do that all the time.
Yeah, so do
But
I.
not like right after school.
That's true, after school.
Don't do it.
I'll tell you mine.
Yeah, like
Another
that.
time.
I do it right after school.
The sign's more of
Yeah.
a recommendation.
Or
It's all
like
the
when
bus
we go
stop.
out.
So are stop signs with white, with white
All right.
those are also recommendation.
I
I don't know
have
if I have to do.
Any more time?
I don't think I'll be able to make it. 'cause
Everyone's good?
they just-
Yes.
Okay, let's go through the answers real quick. All right, so, on this one, let's get rid of that. Okay, these are constants. They're gonna be nice, clean numbers. So on the first one, this is a closed circle. I'm trying to put red here. I'm gonna plug in -1 first, and any number less than -1, so I'll just plug in -2. This is a closed dot. It has a bar underneath it. Now here's the easy part. Since this is just a number, there's no x to plug into. You're just gonna have that answer the whole time. Doesn't matter what x number you pick, because there's no x's to plug in, so it's just a 3 the whole time. So -1, 3. That is an closed circle, has a bar underneath it. -2, 3, and it's going that direction. So it's a horizontal line ignoring my tilt. The second graph, if I do the second one, I'm going to plug in a -1. That is an open circle, and I'll plug in any numbers greater than -1. So I'll just plug in a 4. It doesn't really matter what number I pick. The answers are always -3. There's no x's to plug in, so I just get -3 the entire time. So -1, -3, open circle, 4, comma -3, and there's your graph. Okay, so it should be 2 horizontal lines, 2 constants. Questions on that one? Hopefully if you made any mistakes, go fix it. The big thing to check for is open, closed circles, arrows going in the right direction, that type of thing. Okay, questions at all? All right, let's go to the next one. All right, let's unfreeze this. All right. Okay, next one. Okay, so now we introduce a curve. So now we introduce a curve. So now they're starting to get a little more challenging. Okay, you got certain x's you can use. I want to know open circles, if they're just lines like tilted, if they're curves, try to put in a couple numbers. If you have a fraction on yours, just divide by the bottom number. That's what you do. I'll give you your answer. So keep that in mind. Okay, you have 3 minutes for this one as well, and then we'll kind of talk about it. And we'll have one more after this. And that last one we will not go over, you'll just have to turn it in. So this is to give you a chance to kind of try it yourself.
X is
Yeah,
less.
you can talk to your neighbor and all that good stuff if you need to figure it out. So I'll give you 3 minutes. About a minute and a half left.
Yep, all by track.
Is that right?
Mine overlaps.
So does mine.
No, is this first one there?
Yes.
Is this supposed
Exponent?
Should I have an exponent?
to? How are they both?
That second one's a line.
About 30 seconds left.
Yeah, you can, with the slope.
Yeah, we'll go over it, let's make sure if you need to make fixes, somewhat. And I wanna go through these in class, so you get a
Slow.
chance to try, yes, get a chance to see somebody else, attempt it, talk to your neighbor.
This one's straight.
It's about right.
It's straight.
She's straight. Straight as can be.
Straighter than a board.
Straighter than a man.
Okay, we're good so far?
Straight as a circle.
Okay, alright,
Let's
hey, let's walk through it.
They overlap.
Alright, Hey, here's the answer for it. So first one, it's an open circle. I'm going to plug in a 1 and any number less than 1. Now this is a curve. We can identify it's got a power. So I'm going to plug in a couple different numbers. 0, 1, 2,
Almost done.
3. I don't care how many you plugged in. I just need to get a sense for where this thing is going.
Any negatives.
Negative 1. Sorry.
Well, you are
1,
not-
negative 2, negative 3, negative 3. Sorry. Yeah. So okay. So I'm plugging in those numbers. When you do this, you got to square the number first, then cut it in half. So when I plug in 1, so if you circle the less than 1, this would be an open circle here. I'm going to plug in a 1. 1 squared is 1. Cut it in half, get half. When I plug in a 0, 0 squared is 0 times half is 0. Negative 1 squared is 1. Cut it in half, get half. Because the squared gets rid of the negative. Negative 2 squared is 4. Positive 4. I cut it in half, I get 2. And negative 3 squared is 9, cut it in half, I get 4.5. So there's my dots that I have. Now, obviously they're squares, so it's going to turn everything positive. So I'm going to have 1 comma half, and that's an open circle. 0, 0 is closed, 1 half, 2, 2, and 3, 4 and a half. And this is what it's starting to look like. I get a sense for where this thing's going.
Got it.
All right, now the next one. The next one. I'm gonna put this next one here. I'm gonna plug in the number 1, and this is a closed circle. Then I'm gonna just plug in a number greater than 1, because I know this is a line, so I can just plug in one more number. I'll plug in 3. It doesn't really matter what number I plugged in. I'm just picking a number bigger than 1. All right, so 1 plugged in. 1 times 2 is 2. Minus 1 is 1. If I plug in 3, 3 times 2 is 6. Minus 1 is 5. So 1, 1, closed circle, and 3 comma 5.
C rate.
All right, and it's straight line going that way. All right, there you go. It kind of looks like it's almost like a closed, like, parabola, but it's not. There's actually a tiny bit of a gap
There's a
there
half-inch gap.
between, you know, that half and the 1 that's above it. Now, range-wise, the lowest range number, like the lowest point, is a 0, 0. The highest point is non-existent, it doesn't exist. Its domain is all real numbers, but the range is also like from 0 and up. Even though there's a gap here, the gap is actually filled in by this side. But continuous, discontinuous, that type of thing. Decreasing and increasing.
Lock it up.
It is decreasing to here, and then it's decreasing over 2 different intervals on this side. So if you had to do something like that. All right, the last problem, this is one that you just have to do on your own. It's got kind of everything mixed together in a
No
one
way.
problem.
Cheese and newsies.
This is one we're not going to go over together in class.
What's it called?
Once you have it finished, done, complete, you'll turn it in, you're done for the day. So, there's no time, you just have to finish it up before you
Well,
leave.
there's 4 minutes.
Alright, here we go.
That ain't
You're
it.
frozen.
That's not
She
it.
frozen.
That ain't it.
There we go.
Here we go. It's got 3 parts, 3 distinct graphs. The first one is 0 for any x less than 1. The next one is negative x for any x from -4 up to 0. Noticing I'm giving you the 2 numbers automatically, like there's a set band that you have there. No open circle or closed there. And then the last one's a curve, that type of thing, and you should know where to draw. Okay?
Why'd you flip it?
So
Oh, that's true.
So there you go. Take your time. It's due before you leave, and that's what the first class is rushing to try to get done today. They're really struggling on this one.